Okay, so we're going to take a look at negative exponents and zero exponents in this quick little video. Let's start by reviewing what we already know from before, which is that if I have this expression right here, I know that I've got 4x's in the top and 3x's in the bottom, and we saw that what happens is those first three sets here cancel because they're equal to 1, and then all that's left is basically an x over 1, which means this is equal to x to the 4 minus 3, or just x to the 1. Now when there's an exponent of 1, it's not necessary to write it. This means the same as this. But what would happen, just for the sake of argument, if we had an expression like this? Let's say we had x to the 5th over x to the 5th. Well, you probably remember that any number over itself equals 1, but in case you didn't, let's just look at how this plays out. 5x is on top, 5x is on the bottom, and what ends up happening is each of these is basically equivalent to 1. 1 times 1 times 1 times 1 times 1, which means our answer is 1. But if you remember our subtraction rule from up here, if we apply that, we realize that x to the 5 minus 5 equals x to the 0, but we know from what we just did that that equals 1. So the bottom line here, as long as the number involved, the base is not 0, any number to the 0 power will always equal 1. Now let's take a look at negative exponents and how they might act. Let's look at m squared, which is m times m. And then on the bottom I have 5m's being multiplied together. And we should know that this, as we've seen so many times before now, m divided by m is 1, m divided by m is 1, and then I've got 3 m's left down there in the denominator. And so what we realize is that this is just 1 times 1 times 1 on the top, and then there are a total of 3 m's in the bottom. So this expression is equal to 1 over m to the third. But again, remember our subtraction rule. If I apply the subtraction rule, what I would do is I would take 2 minus 5, the top exponent minus the bottom exponent. Well, m to the 2 minus 5 gives me m to the negative 3, which we also know is equal to 1 over m to the third because of the math that we did up here. Now where it gets really interesting is in cases like this, and you'll see this in IXL. If I asked you to evaluate 1 over x to the negative second, notice that here the relationship between these two is basically what's called a reciprocal. So the number turns upside down, it flips. And the same thing happens wherever the negative exponent is, so that this is really equivalent to 1 over x to the negative second power is really equivalent to x to the second power over 1, or x squared. So the bottom line here is when we've got a negative exponent and we're trying to express it using positive exponents, we have to use the reciprocal. So it goes from being negative on the bottom to positive on the top, or as we see here, it goes from being m to the negative third in the numerator down to m to the positive third in the denominator. It's a little confusing, but you get used to it, you'll get the hang of it.